3 plus 1, and then 4 plus 1. Agree? Odd factors you have to find out. So remove all the 2's and then find out the factors. So 5 raised to 4 you have then 4 plus 1. 5 odd factors are there. Multiple of 10. How will you do, sorry, a multiple of 10?
एक सेकंड मल्टीपल ऑफ 10 के लिए
You take 1, 2, and 1, 5 out.
You
हाँ
for multiple of 10, 1, 2, and 5 out. Perfect. So then how to find out like ठीक है, multiple of 10 you understand 1 5, and then multiple of 100 you take 2 5 2 10 out. Is
Yeah.
how will do is square factors.
yeah
Square factor.
uh it has 1 until 1000 तो है ना 10,000
So you can find out the square factors. Square factors, you have to write something square into multiplications remain. Agree? Something square means maximum what you can put here. Like you can put 2 raised to 2 and 5 raised to 2 and then 2 into 5 here. So factors inside the square would give you square factors. So inside factors, how many you have? 3 into 3. So there are 9 square factor. To do cube factor, you have to do same thing. You write something cube into remaining. Something cube maximum you can put 2 into 5. Remaining is 2 raised to 2, 5 raised to 2. It does not matter what you have. This would give you what? 4 factors. So there are 4 cube factors. So what is the additions of the factors and what is the multiplications of the factors? How to get additions of the factor if you have 2 raised to 4 into 5 raised to 4 as the prime factors?
So you do 2 raised to 5 minus 1 upon 2 minus 1 into 5 raised to 5 minus 1 upon 5 minus 1. And then you multiply.
Understand? So this you understand. So perfect. So you like what is the additions of factor? 2 raised to 5 minus 1 or 5 minus like 2 minus
2
1.
minus 1, 2 minus 1.
Perfect. Into 5 raised to 4, 5 minus 1 over
5
5.
minus 1.
And what is the multiplications of factor, beta? So see, to get multiplications of the factor, write number, whatever number you have, raised to number of divisors of this divide by 2, because those get paired and half pairs is like going to be that only. So this, so how many factor it has? 25? So 25 divided by 2. This is 10 raised to 4 raised to 25 divided by 2. So this cancel out to 2. So 10 raised to what you will get here? 50. Okay. So now I'll take more examples on that. Like see, if I have 12 and I want to get it like multiplications of factors. So what are the factors here? So you have 1, 2, 4, you 1, 2, 3, 4, 6, 12. Now see multiplication of factor, you see every pair is getting multiplied to कुछ गड़बड़ लिखा है क्या? Same number you can see. So there are half of the number of factors into and half. So that is why 12 raised to, if you multiply this into this, you'll get 1 into 12. One pair. If you multiply this into this, 2 into 6, another pair. If you multiply this into this, 3 into 4, another pair. And thus this gets into multiplication. So you'll get 12 into 12 into 12. So 12 raised to 3. Agree? So that many factors you have in the multiplication. Okay. So that's what it is. So multiplication of factor, everything you understand. Can we discuss about symmetry of the factors? So see, if I have 1, 2, 3, 4, 5, 4, 6, 12, what is the symmetry of the factors? So if you divide into two parts, this side and this side, isn't like half of the side is like lesser than like and half the numbers are more than the numbers. That's how the symmetry of the factors also there. ये तो आता है तुम लोगों को, ये तो बिल्कुल कोई प्रॉब्लम है नहीं इसमें से आई थिंक. If I have 12 18, how to get GCD of it and how to get GCD. Chalo, 12 18 24. Can you find out GCD and LCM of this? Did you how to get GCD?
GCD would be 6.
So how will do it? 2 raised to 2 into, for doing GCD, you write into the prime base like exponent. Then this one is what? Isn't this is like 2 into 3 raised to 2, and then 24 is what? 2 raised to 3 into 3. Now to get GCD, you have to take the lowest power of 2 in either of that. So the lowest power of that is what in this full, the lowest power is 2. And then 3 ka highest power, like lowest power you take, which is 3. So perfectly you said 2 into 3. And what is the LCM of that, beta? You take highest power, agree?
Yeah.
2 raised to 3 and highest power of this 3 raised to 2. So sometimes you require GCD LCM, so that is like that also you understand. Now we're moving ahead. You this much you know very perfectly. This is not required much. Modular arithmetics, you know properly how to deal with modular arithmetics. There is no issue in modular arithmetics also. Just let me take one question. If I have 7 raised to 1000, if I do like what remainder I get if I divide it by 8. Can anyone tell me? बोलो. Riddhi, what do you think? If you divide by 7, you divide by 8. What is the remainder? Tell me. 7 only?
Yeah.
Can you write this -1?
Hmm.
If you multiply two sevens and you want to get remainder, what is remainder? This will give -1. This will give also -1. A mod 8. This one is what combined? 1.
Yeah.
A mod 8. Understand? So if I
Hmm.
take like 7 cube, what it is? 7 into 7 into 7, and that too also congruent to 1 mod 8. Okay. So this this would give -1, this would give -1, this would give -1, and that would become -1. Agree?
Yeah.
So what we can conclude it here, if this number is 1 before than that, then you can replace it by -1 and put the power, what power you have. Okay, that would give you A mod 8. This one is like A, मतलब 1 only, no?
Yeah.
What if this is 9? Is it same as 1?
Yeah.
And what if this is 10? Tell me, what is if this is 10? So if this is 10, so 10 raised to 10,000 will give you what A mod 8. Tell me what is it? Can anyone tell me how to proceed in this question?
Sir, if we first thing, I think we can make the 10 or 2,
Perfect.
and
2
then
raised to 10,000. Then since isn't this multiple of it? Because 3 zeros are there. So like you will have 8 raised to perfect power. It's a mod 8. Isn't this is 0?
yes,
Because if multiple of like 8 is what? Last 3 digit has to be divisible by 8. Agree? So you can break it like 2 raised to 3 raised to something. Okay. So no, this is not, no, that is wrong. This is not, this has to be divisible by 3. So you think this way, if you have 2 raised to, agree, you have 2
sir,
raised
if we take
to,
10,000 and we
then you will
like
take 9999 beta into 2. Agree? Then we'll do that would be what? A mod 8. Agree? So this value is what? 8. This would give you what?
0,
0. So 0 into 2 is 0 only. Agree? So that means it has 8 as a factor. So you divide by it, that get cancelled out. So there's no remainder. Agree? So that also, that way also you can think. Okay. What if I have 7 raised to and 1000 and I'm saying what is this a mod 10? Because I'm asking you what is unit digit of it. What will you do?
uh, I think it's a 0 only mod 10.
No beta, 7 raised to 10,000. Mod 10. Mod 10 matlab hota hai ki if you divide this big number by 10, what is remainder? That a means. So if you divide 7 raised to 1, you'll see it is 07. Agree? 7 raised to 2, it is 49. 7 raised to 3 is what? Huh?
49.
Yeah, so through cyclicity.
7 raised to 3 is what? Riddhi? Isn't 243?
Yeah.
7
Yeah.
raised to 4 is what? 729? Is it? You
No,
multiply
2401.
2401. Agree?
Yeah.
2401. So the cyclicity means if 7
Two,
divided by
no, so there'll be a 0
Acha,
between 4 and 1.
0, 4, 0, 1, no?
Yeah.
Okay, so if you divide this by 10, what will give you 7 as the remainder? If you divide by 10, it will give 9 as the remainder. If you divide by 10, it will give you 3 as the remainder. If you divide by 10, it will give you 0, 1 as the remainder. If you take next number, which is 7 raised to 5, you again multiply 7 on it, you will get 2407. If you divide it by 10, and then you need this unit place number. That is also again 7. So start repeating what it was here. So that is here again coming. So if you want to do 7 raised to 10,000 and you want to get remainder, what need to be done? Then
It's 7.
it's like 7 raised to 4 into 7 raised to 4 into 7 raised to 4. That way you can break it because multiple of 4 it is. So 7
Yeah.
raised to 4 would give what remainder? 0, 1.
Yeah.
So this also will give 0, 1. So every number will give 0, 1. So answer is what?
1.
1, not 7.
1.
7 is when you like 4n plus 1. Riddhi, if you have 4n plus 1, where n is positive integer, will give 7. Agree? 4n plus 2 would give you what? 14, like 9. 4n plus 3 will give this. So that much you understand.
Yeah.
So sometimes what happens when you see the power is too high, power in this is too high, then there is some changes that you can, there's some theorem that you can apply. Just like one theorem is if you have a raised to p minus 1, it would give you one remainder if it is divided by if this is divided by some prime number p. This is called Fermat-Little theorem. Euler-Sedney Fermat-Little theorem. Okay, this is called Fermat-Little theorem. So one thing is there here. See, this is called Fermat-Little theorem. So first, like just apply this. Take 7 here. So if you have a raised to 6, which is 1 less than, that would give you one remainder if you divide by p. P7. Agree?
Yeah.
Now, what I can put here, Anvika, what I can put in place of it?
So what do you mean put in place?
So see, this A is co-prime with respect to this 7. Whatever you divide that. So you can put any number which is co-prime with this. Means you can put 2 here, 3 here, any prime number, because this will be co-prime with 7 only. Okay? 2, 7, even you can put 4 also, you can put 5 also, 7, not 6 also, anything you can put. So if I say 2 raised to 6 congruent to 1 mod 7, means 2 raised to 6, if you divide by 7, that would give 1 remainder. And you can check it, 2 raised to 6 is what? 64. If you divide by 7, that will give 1 remainder, because multiple of 7 is closer to that is 63.
Yeah.
Okay. So you can see 3 raised to 6 is 1 mod 7. This is called format little theorem.
Yeah.
Okay. So that's how it is. So what is the use of it? Why I'm doing this? But because see, if I have like, I want to simplify lesser. If I have 3 raised to 1000 and I want remainder, what is remainder? If I divide by 7, Anvika, what will you do? Like, how will you do that?
So I think I would
You
divide
just break into 3. 3 raised to multiple of 6, not 7.
Yeah,
Multiples of 6. So beta, if you divide 1000 by 6, what remainder you will get? You try to find out that first. That would help you better. So isn't like see the closer number which is multiple of 6 to the 1000 is in 996.
Uh-huh.
Because 999, see, to be multiple of 6, it has to be multiple of 2 and multiple of 3. Means even number multiple of 3. So this is 999 is odd number multiple of 3. This is even number multiple of this is closer and lesser than 1000. So we would take this as the last number if 4 remains. So we can break it and we can write it like this plus 4. So the 3994 into like 9 and 6 into 3 raised to 4 congruent to A mod 7. Okay. This we can break it 3 raised to 6 as many as like I think 166 or 167, something like that, into 3 raised to 4. That would give you A mod 7. Each and every value by using this theorem, this into next will become 1. If that
So
bit,
the final answer will also be 1.
maybe, but the 3 raised to 4 remain better. So 3 raised to 4 we have to simplify. Till here it is fine, but this extra is there, na? Because that was like this is multiple of 6, but this is not multiple of 6. So 3 raised to 4 is 81. You have to divide by 7. What remainder will get you to work on?
11.
7 multiple you go 70, 77, 4, no? So the answer is 4. Agree or not? Any problem? So multiple of 7 is 77, close to this. So how much remains? 4, no?
Yeah, 4.
4. So remainder has to be 4, I think. Any cross question on that you didn't understand, understood or any?
Sir?
Huh?
Could we have used Euler's theorem for this one?
See, this is the form, Euler's short form of the Euler. This is one case of Euler theorem. Euler theorem, you have to find Euler-Tocen function. So 7's Euler-Tocen function is only like 6. So that is like indirectly Euler theorem only. This is a special case of Euler theorem. Agree?
Okay.
So
Yeah.
if I write another number in place of this 3, suppose 5, will it work? It will work. If I write 6, then will it work? It will work. Understand? So that big index 6 to anyway you know it what to be done. 6 you write then 1 lesser, then you can use now normal like theorems to like simplify that. I am very happy that you are understanding that. Now up there, let us do Euler's theorem. What Euler's theorem is? See, the problem with this is if I take something this is not prime, because that was working for prime number. So prime number is like, but our constraint is like till prime number. Suppose I want to divide it by 10. Then I want to do it. Then how I will do it? If I divide it by 10. So then that is not prime, no? So there is something called, one more theorem is called A raised to tocent of n congruent to 1 mod n, where n can be anything. Only constraint is these two has to be co-prime.
Okay.
Okay, so up now, if I take here 10, here 7, so if I have 7 raised to this, and I want to do 1 mod 10. Okay, now this is not prime number. Okay, this is co-prime. Yes, this is co-prime with that. Okay, so for what point 7 raised to like p congruent to 1 mod 10, first have to find out. If this we get the repetitions of it, then our work will be done. So what is 7 raised to p congruent 1 mod 10? Think first toscent functions of any function n is n times 1 minus 1 over that 1 prime factors of it and into 1 minus other prime factors of this and all the prime factors that you just do. Just like here, what prime factors of 10 we have? 2 and 5. So you write here 10, 1 minus 1 over 2, 1 minus 1 over 5. So you'll get 10 into 1 over 2 into 5 over 4 over 4 over 5. So this 10 cancel out, so 4. So means 7 raised to 4 will give you 1 mod 10, though this is not prime. Okay, so up now you understand the same. This is like more like cyclicity only, na? Then you dividing it, so cyclicity of this is 4. So Riddhi, now it is quite easy, na? Now, so because cyclist, this you got 4 only. Chalo, I want to do for like abhi I want to divide it by like suppose 12. How I'll do it? 7 raised to a, like 7 raised to a congruent to 1 mod 12. What this a would be? Quotient function? How to
Function
get
of 12.
quotient function of 12 is 1 minus 1 over what it is?
2 and 3, right?
And 1 minus 1 over
3, yeah. So it'll be 12 and a half into 2 by 3, which is,
so 12 into half into
I think it's 4.
2 by 3. So this cancel out to 2. So that is
Yeah, it's 4.
4.
Yeah.
So like 7 raised to 4 is 1 mod 12. Means if you divide 7 raised to something by 12, the cyclicity is 4. Every 4 it start repeating. Okay, so that's how we can simplify it more and we can use where the prime number is not there. Okay, so I'll take a question, just like I have 7 raised to 101. I want to divide it. What is remainder if I divide by 101? Tell me. Riddhi, tell us.
So do we have to use the Euler's theorem?
अब आप सोचो यूज करना है कि नहीं, पहला स्टेप तो यहीं पे आता है. We can use it, no? Euler, this is prime number. Without Euler theorem also will work. These are prime number. This is prime number. Then of course they are co-prime. So 7 raised to 100, okay, will give 1 mod 101 because 101 itself is a prime number. Agree? So this would give you 1. So what remains here? 7 congruent to like a mod 101. And that means if you divide this number by 101, that remainder is going to be 7.
Okay.
Agree? Why? Because this is prime number, this is prime number. So first condition is they are co-prime. Of course they are co-prime. Second condition, if this is prime, then and they are co-prime, then 7 raised to n minus 1 would give you 1 mod 101. Because these are co-prime and this has to be 1 lesser than that, and that is 100 total. Okay, so 7 raised to 100 would give 1 mod 101. Anyway, if you want to find out toscent functions of 101, so this would give you 101 into 1 minus 101 over, what will give you? 1 over?
101.
101 only.
then 100 it will give. Now see,
Yeah.
one prime number, no, 101 will place it here. So 100 into 101 minus 1 over 101. So this is cancelling out, but this become 100. That is always, if the prime number you have only one factor and then one lesser than the number is always tosine function. That is why the theorem, Fermat-Little theorem works like that.
Mhm.
Okay? You understand that Fermat-Little theorem also, tosine functions also. Now, if moving ahead, if I have 7 raised to 100 and 8 raised to 100 and 9 raised to 100 and 13 raised to 100, and if I want remainder A, if I divide by 11, okay, without doing anything, can you tell me the answer? Without doing much work.
I will try Jimka this. I will try Jimka thing, then we will do together here. Even done first.
Bolo, don't do much, just think and tell me. So see, look into the rules that we have learned it. If you divide by 11, these are the co-prime. Look at the first. If this power is 1 lesser than the power, matlab 7 raised to 10 would give you 1 mod 11. Agree or not? Okay. 7 raised to 10 would give 1 mod 11. Agree? Why?
Yeah.
All the conditions are fulfilled. This is 1 lesser than this prime number and these are co-prime. So if I change the 7 raised to 100 to 7 raised to 10 raised to 10, what it will give me? 1.
Yeah.
This will give me 1 raised to 10 is what? 1 only. This is also co-prime with this. That also will like same 10 will give. So everything will give 1. So answer is going to be what? 1. Understand? So though it looks so heavy, but like you can do that way. Okay. Okay. So let's work on like 7 raised to, like suppose you'll take 1000 and you want a mod 100. How will you do that?
So we can do tosine function of 100 and find it, right?
Tosine function of 100 is what? This is 100 into 1 minus 1 over 2 into 1 minus 1 over 5. Okay. So then you will get like 100 times 1 over 2 times 4 over 5. So this would give 10 into 4. So that would give 40.
40.
The tosine function of this is 40. Means it repeats into the 40. Means if I write 7 raised to 40, that would give me 1 mod 100. Means if I divide this by 40, that would be 1 only.
Yeah.
Okay. Means if this power is multiple of 40, then the answer is going to be 1.
Yeah.
Is it multiple of 40?
Yeah.
Yeah,
It is multiple of 40. So multiple of 40 means the answer is like 7 raised to those so big numbers you have and divided by big number, that would give you 1 only.
Yeah.
Perfect.
Yeah.
So these kind of questions you have to get used to of. Now, see, if I have like 13 raised to 1000, okay, and I want to get like remainder, okay. If I want to get 1 more, like I want to get a mod 100, how I will do that question? That is very complicated question. A mod 100.
And this not be 1 as well.
So it's just 1, right?
How do you know it's 1?
So because
That
you do
says the same rule.
the same thing you did below. So you just do the totient function, you get 13 raised to 40.
Again. Perfect. Like very nice. Sorry.
Oh,
Yeah.
I'm always say 1, 2, 3, 4. I want. थोड़े तो it is difficult now. Arus isn't difficult now. Did we learn Chinese remainder theorem?
Uh,
तो हमने
no,
किया
Apply it, child. So I'll tell you. First, break this 100 into 2 co-prime. So those are 4 and 25.
yeah.
Agree? So you find out like 3 raised 13, 1, 2, 3, 4, congruent to A, mod 4. Find out 13, 1, 2, 3, 4, congruent to B, mod 25. First, you do just calculate that. Okay, how will you calculate this? Tell me, how will you calculate? Isn't this is one more than this number?
Yeah.
Like one more than multiple of this number.
4 to Z.
Okay, so one more than multiple of this number. So see, if you want to evaluate this, you can use like इसका tosant function का तो बहुत छोटा होएगा, क्या ही जरूरत है. पर अगर हम इसे one more than, we can write 1, 1, 2, 3, 4. That would give one mod. ठीक है, 4. Okay, so this is getting simplified to 13 raised to 1, 2, 3, 4, getting simplified to 1 mod 4.
Okay.
Okay, now can you simplify this same way? Can you divide this by 24? What is the multiple? Like, how will you reach it to the, if you do, how will you divide this by like 25? Something you have to simplify to reach it to the remainder.
so if you take like 13 into 2, but I don't know, I don't think that will work.
Don't
13
you just like you find out tosant function of that. What is tosant functions of that?
Yeah.
20? 20.
Yeah, it's fine.
So 25 into 1 minus 1 over 5.
Yeah.
So 25 into this is 4 by 5. So this cancel out to 5. So what it
Right.
is? 20.
Okay.
Okay. So the value of this is what? 20.
Right.
20. So value tosant function is 20.
Mm.
So what is closer to multiple of 20 of 1, 2, 3, 4? Tell me, because we have to write up these powers.
1, 2, 2, 0.
1, 2, 2, 0, no?
Yeah.
So you have 13 raised to 1, 2, 2, 0. And if you do, this would give 1 mod 25. Agree?
Yeah.
So
Yeah.
the remaining part of this is what? Like 13 raised to
14.
14 is equal to B mod 25. Now our problem reduced to this.
Yeah.
Okay.
Oh, so
you-
now such. Yeah, okay.
Now
Yeah.
you try to find out, you can write 1, 3 raised to 2 raised to 7. Something to we have to do it. There's no other way. We don't know much power of like 3 raised to 2 also. So we can reduce by this way. Mod 25. Okay. What is that? Tell me. 169?
Yeah.
So 169 if you have, so if you divide by 25, what will you get? Remainder.
So
19?
yeah, 19.
So you can write this 19 raised to 7 congruent to B mod 25. Any problem?
No.
So what is 90? Now 19, if you divide by this, you will get 6 minus 6. So can you write minus 6 raised to 7 congruent to B mod 25? You have to reduce anyhow. Just do whatever you want to do it, but just reduce it. If you took 6 raised to 2, that's 36. If you divide by this, what you will get?
That's
6
the
raised to
remainder,
2 is
right?
36. Remember,
Okay.
36 divided by 25 would give 11.
Yeah.
How many such 11s you have?
7.
3 and then minus 6.
Okay.
That would give you B mod 25.
Yeah.
Okay.
So how I'm confused, what did you do here in the
See,
last step?
did you understand here till here?
Yeah.
So see,
Yeah.
I wrote it minus 6 raised to 2. So which is what? 36? 36
Oh, okay.
divided by 25, what will give? 11?
Yeah.
Okay,
Yeah.
so that's how I got this. Okay,
3 times.
because like you break it -6 -6 -6 3
Yeah,
no?
I got it.
Actually. Okay. Got it.
But
-6
how did
raised
we
to
get
2 -6 raised to 2 no, so 36 136 divided by 25 will give what?
That's
11.
11?
So
Yeah,
that's what it is. That's what we've done it. So here till we reach it. Now, 11 raised to 3 is what? 1, 3, 3, 1. Agree?
yeah, yeah.
If you divide by 25, so first you just be sure, if you divide by 11 raised to 1331 by 25, what it will give you? 331. See, the square, if you do 25 raised to 2, 25 raised to 3, anything, so isn't this is multiple of 25 is like 1325, and then this is how much away? 6, no?
Yeah.
So that would give 6, no? 6 into
6 into -6,
is
which is
b
basically
mod
36.
25. So this is
Yeah.
minus 36.
Oh.
So
Yeah.
minus 36, you want to make it plus, then you add 25. So minus 36 plus 25 is minus 11.
Hmm.
Minus 11 plus 25 is what?
It's,
It's 40.
14.
So the remainder is what? 14.
14.
So I got one thing. My problem was 13 raised to, I don't know, 1, 2, 3, 4. And I had to find out a mod 100. Means I want to find out last 2 digits of this. Riddhi, are you understanding better?
Yeah.
Are you sure? If you understanding, I'm very happy. You are in 7th to 8th grade, you understanding. Okay, so let's move ahead with this. Since Riddhi is understanding this, we are going ahead with this. And now, see, Riddhi, we changed this into 2 problems. One problem was like 1, 3, 1, 2, 3, 4 would give me what remainder? 1 remainder if I divide by 4. Okay, and this 1, 3, 1, 2, 3, 4 would give me 14 remainder if I divide by 25. Now I assume that this is some x. So this is x would give me 1 mod 4, and this x would give me 14 mod 25. So can you tell me one thing, Ayan? Isn't like this is 14 away from multiple of 25?
No.
So I could write this x as what? 25, suppose t plus 14.
Yeah.
I can write, no?
Mhm.
So I got it from here, but these two are same x. Agree? I could place it this x over there. Can I do?
Yeah.
So if I do it, what I'll get?
Yeah, 25.
25t plus 14
Mhm.
is 1 mod 4.
Yeah.
Okay. So if I divide this by multiple of 4, what it will be? 2.
Yeah.
Okay. So see, this is 2. If you subtract 2 both sides to eliminate from here. So 25t would be minus 1 mod 4. Agree? Any problem? So see, isn't this is 1 if you divide by 4, because 24 plus 1. So t is minus 1 mod 4 means 3 mod 4. Any problem? Minus 1 means what? You add 4 on it to make it positive because you're dividing by 4.
Mhm.
Understand? So t has to be what? T has to be like multiple of 4 plus 3. So multiple of 4 plus 3. So I added a more variable, 4s plus 3.
Yeah.
Okay. So where t is here, no?
Mhm.
So this x is changing into 25 into, I will replace it by this, what it is? 4s plus 3
Mhm.
plus right side is what? 14.
Yeah, plus 14.
So x is what? This multiply 100 s plus 75 plus 14.
Yeah.
So x is what? 100 s plus this add up to
18.
what number? Huh?
Yeah, 89.
89. So the x was what?
X.
X was
Yeah.
13 raised to 1, 2, 3,
4.
4. You can write multiple of hundreds plus 89. So if you write 1 here, what it will give you? This.
Okay.
Okay. So what I'm trying to say, if you divide this by 100, you'll get these kind of like numbers which fulfill that conditions. Okay, if you write one, what will you get? 189.
Yeah.
Okay, so if this number you divide it by 100, then you'll get 189. Okay, and if you write two, then other number, other number as the remainder.
Mm.
Okay, so actually remainder is what when you put zero. So because number has to be less than 100. So
Yeah.
you put zero here. If you put zero, then 89 is the answer.
Yeah.
Everyone understood this? Or I have to go again full descriptions?
I got it.
But sir, can't you use cyclicity? Like
बेटू
for the first
30
question.
रुक जा cyclicity use for 100
Yeah,
cyclicity
yeah.
40 then 40 13 का table you should know 13 का table are up till 40. So after reducing by this cyclicity, when you use the cyclicity of like tosant functions of 100 is 40. So 30 का you have 40 के बाद repeat करता है. तो 40 remove करके whatever that you have to simplify by 100. You can do that also. But bigger problem is what if I increase this number to one more zero?
Mm.
Okay, then cyclicity won't work. Cyclicity then will be in hundreds. Okay, so this, if you understand this full concept, I can give one, two more question because this is like, it is not that easy to do it. I can explain the cyclicity also very different way. Like I prepared lectures also today. I spent 3-4 hours. See, cyclicity, I just put everything very differently now. But last time I thought they didn't understand. I was very upset why my kids didn't understand. Then I put 3-4 more hours to align the document. Anyway, everyone understood this.
Yes.
So I'll move ahead with like one more question because this is like very different questions. So if I have suppose 1, 2, 3, अभी मैं मतलब अच्छे क्वेश्चन ले रहा हूँ जो एमसी से भी थोड़े ऊपर है पर लॉजिक डेवलपमेंट कर रहा हूँ जिससे कि मेरे को मतलब 1, 2, 1 suppose raise to I'm taking like 1 to 1 and I'm doing mod 100. So we have to use the same method we used. Let's do by that method. Okay. So we don't write 11, we write 121. चल अच्छा write 11 raised to या something 1 write 1, 2, 3 कर लिख ले तो थोड़ा हाँ मतलब तो फिर थोड़ा easy हो जाएगा. So what we'll do, we'll break it into two. One is 4,
25.
one is 25. So if I break it into two, then I'll write 1 to 3 raised to, ठीक है?
1.
That one, like first though, we'll do this raised to 124, 121 mod 4. And then second we'll do 1, 2, 3 raised to 121 mod 25. If you do this, what will you get? ठीक है? So tell me.
I used cosine.
अरे 4 का मल्टीपल है ना भाई, कुछ करने का जरूरत ही नहीं. Isn't this is 4 का मल्टीपल 120? So you write 124. So -1 raised to 121, no? So -1 raised to 121 will be what? -1 only, no?
Yeah,
Because
-1
odd pair,
only.
-1 means 3. So this would be like C. So that means 123 raised to 121 congruent to 3 mod 4. Okay, and if this is 25, so this is closer to 125. So -2 raised to 121 mod 25. Anyway, you have to simplify.
Mm.
Okay, so tosant like abhi this, if you make like -2, then you can make it like 1, like isn't this is 2 raised to then 2 raised to 120 mod 25. Agree? So see, the Tochin functions of this is what?
That's 5.
Hmm?
That's 20.
Tochin function of this is 20. So this
Yeah.
is multiple of 20.
Yeah.
So this completely gone.
Yeah.
So this completely gone -1, or then you add 25 in it to get that. This is 23. So 123 congruent to 1, 2, 1 would give you what? 23
Yeah.
mod 25. Okay, now you have like 123 raised to 121 is equal to a mod 100. That is your problem. That broke into, from your knowledge, it will be like 123 raised to 121 would give you a 1, no?
Yeah.
Mod 4. And this 123,
23 mod 3.
121 would give you 23 mod 25.
Yeah.
Now, if you have to combine it, the rule for combination says what? You assume this as x. This is also x.
Yeah.
Okay.
The first one, 123 to the 121, 3 mod 4.
Which one? This, sorry, this was 3 mod 4. So, like that, agree? Now, always take the higher value one here. So, you write this, since this is multiple of 25, agree? So, x is going to be 25s plus 23.
23.
Okay. Now, if you replace this by where? Replace this by, like in the other equation that you have, x is equal to 3 mod 4. So if you write here, so 25s plus 23 congruent to
3 mod 20. 3 mod.
So then the plus 23 will
mod
just become
25.
-1.
So, so just like
Oh
25.
no, wait, my bad.
This is
It'll
4.
become -2.
So
Okay, then
just
it'll become
anyhow,
-1.
this is 3 no? Now.
Yeah.
3 cancel out. So isn't this is 25s congruent to 0 mod 4?
But how do you do 23?
So how did they cancel out?
Yeah, how do
I'll tell you.
cancel?
I'll tell you. See, 23 is how far from multiple of 4? 3.
Yeah.
So this is reduced by 3.
Oh.
If this
Oh.
is reduced by 3, then this 3 gone, no? Because you subtract both sides same number. Agree?
Yeah.
This is gone. Now 25 mod 4 is what?
So just
One.
be at, it'll just be 1.
124. No, 1. So this disappears. S is equal to what? 0 mod 4. Means S is what? 4p is S. So you place it here because X you want in terms of, like you want X, not S. No? This is what? 25 4p
Plus 23.
plus 23. So X is what? This is getting multiplied to 100p plus 23. So when you divide this big number by 100, you'll get remainder 23. Understand?
Yeah.
So that was Chinese remainder theorem. So there were two methods of doing. So one method I completely eliminated because maybe one question comes. So based on this, like there are 2-3 also simultaneous equation we used to get it. Agree? So that is like, I think like I'm very happy that everything is going well today. Like everything you revise what we've done. And now I'm just going to take 1-2 more Chinese remainder theorem per question and do it. If I have X congruent to, okay. मैंने लेता हूँ x congruent to 1 mod 5 and then x congruent to 3 mod 7 and x congruent to suppose 2 mod, suppose you have like 11. You have to find out a number minimum in value of x which fulfills all conditions. Matlab, what is the question actually? If you divide x by 5, the remainder is 1. If you divide same x by 7, then remainder is what? 3. If you divide same x by 2, the remainder is 11. What is that x which fulfills?
By 11, then you know.
So what is that such number which fulfill all conditions? So this is like always done by CRT. That is called Chinese remainder theorem. These are Olympiad type problem when you're 3 or 4. So difficult, little difficult to find out inverse and all that. There are a lot of concept involved. So always we start with the higher one. So if I could replace this x by what? Isn't this is like 11t plus 2? Okay. So this is my first assumption. Because x has to be 11t plus 2. Because that has to be multiple of 11 multiple of 11 plus 2. Now this I replace in here because this is a second higher. If I replace it here, what get 11t plus 2 is equal to 3 mod 7. Now my aim is to write up like these numbers and get the subject. So 11t plus 2 is equal
So
is equal
just
to
divide it by
1
3
mod.
now.
This gone. This 1 mod d7. Agree?
Yeah.
Okay. So now if you eliminate multiple of 7, your problem is going to be easy because you can write 7t plus 4t. Okay. Congruent to 1 mod 7. This is gone because this is multiple of 7. Okay. So 4t is what? Congruent to 1 mod 7. Agree?
Yeah.
Any problem? Now there's something called inverse. Remember what I'm trying to say. If I have 2 congruent to inverse, I have to find out more like 2 inverse mod 5 I have to find out. Matlab, if I divide by 2 by 5, the remainder is 1. What is other number I multiply here? You have to multiply, just like, see, if you have 2 here, and this you multiplying, then that has to be 1. What is that number? That is called 2 inverse because this was 1. Okay.
Okay.
So what you multiply
So I
here?
didn't understand the inverse part. Can you repeat?
So see, if I say I have to find a number, just like 2 here. 2 and then I multiply inverse of 2, that should be giving me 1. Suppose I'm dividing by 5. Agree? This is called inverse of that. So in any number, if you multiply some other number which will give 1 modulus, that number is called inverse of the other number given. In this case, is it 3? If I write 2 into 3, isn't that is 1 mod?
Yeah.
Yeah. Yeah.
So this is 3. Can it be other number as well?
Yeah.
Yeah.
Which
Uh,
You
you can get
can-
-1.
You have to get plus 1 only. Constraint.
Okay.
I mean, so there's a lot of numbers or there's a lot of
There are.
options.
This is the easiest number, but the other number which also fulfill that condition are also called
8.
8 also. Of course, 8. 8 you multiply, kitna ho jayega? 16. So 8 is also inverse of 2.
Yeah.
So this can be 2. It can be 8. It can be anything.
Okay.
So my problem is like here I reached it. I don't want this to be here. No, I have to eliminate this 4. So what I multiply here, that is multiple of 1 more than multiple of 7. So multiple of 7 is what? 7, 14, then you'll get 21. So this is, I think this is the number we're targeting. If I multiply
Yeah. 5. Okay.
5, then 20 हो जाएगा ना? 1 less than है ना? 1 more than होना चाहिए. Nice.
49 and right? No.
Then इसके बाद 28. No. इसके बाद 35. Will it work?
Yeah.
Multiple of
So
4
I'm
into
confused what we're trying.
36.
Huh?
9 4 are 36.
36.
So what are we trying to do?
We're
I'm
trying to
confused.
multiply here something which is 1 more than multiple of this.
Okay. So are you taking a value of 3 or a value like
I'm
the-
writing multiple
So
of
can't
10.
you take 2? Can't you take 2?
Perfect, you can take 2,
Huh.
no? So this is 2. So this would become what? 1 more than the multiple of that.
Yeah.
So that, so we didn't consider 2. So multiple of that is what? Like 1 more than, you wanted 8 and 15 like that. So this disappears. So t is equal to what? 2
Yeah.
mod 7.
Yeah.
So t actually is what? T is like 7s plus 2. Perfect. So here what you write? 7s plus 2. So if you write x, that is the number 11 times 7s plus 2 plus 2. So x is equal to what? 11 into 7
Yes.
times s plus this get multiplied to what number?
That's 24. And if
20. This get multiplied to this number is
yeah,
what?
and then plus 2 also.
So 24. So the x is as of now 77 s plus
24.
24. Now this x I'll put into the remaining equation that I have first one. So
So
x
wait, I have a doubt.
ask
So in the first one in the first function we did like the first part, how
Hmm.
did this value become 2 is my question.
which value this become. So see it was abhi it is this 1. Okay? It is 1
Yeah.
or it is not 1 no? So if you have
Hmm.
like 4t is it congruent to 1 mod 7. Agree? So you
Yeah.
multiply something here and here as well. So if you multiply,
Oh, okay.
you get
Okay,
2.
okay, got it.
So this
Yeah.
become 8t congruent to 2 mod 7.
Mhm.
8 is 1
Okay, got
plus
it.
7, so it will disappear.
Yeah, that makes sense.
That makes sense?
Got
Now-
it.
Now, if I replace this here, what will I get?
Then okay,
Hmm.
that's 77 as
Hmm?
and yeah, it's 11t plus 2 equals 77 s
Mhm.
plus 24. Like
Kitna?
11t plus 2. Or you're placing it in which one?
So you do 77s plus 24 is congruent to 1 mod
No,
5.
you right here. Now here we use both. No, this
Yeah.
we didn't use.
Mhm.
So we have to
Oh.
place it here. So if I place it here, what will get 77s
Plus 24
plus
equal to
24
1
is equal to 1 mod 5. No.
mod.
So पहली बात तो I will remove it छोटा करूंगा. Multiple of 5 close is 75. So 2s plus multiple of close to 5 is 4. Come to 1 mod 5. ठीक है?
So take it as -1 now. Why are you taking it as +4?
That's my
So -1 ले ले तो फर्क क्या पड़ता है इसको उधर तो मूव करेगा ना उधर मूव करेगा क्या आएगा तो 2s इज इक्वल टू कितना आया इधर तो इज इक्वल टू -3 तो 2 आया ना 2 mod 5 एग्री सो अभी तुझे फिर सेम चीज आना है यू हैव टू मल्टीप्लाई 3 टू गेट 1 मोर देन 5 ना ओके सो
Yeah,
disappear so s is equal to what it become
6 mod 5.
6 mod 5 so 5 mod 5 like 1 mod 5 agree
Yeah.
So 1 mod 5. So if this is 1 mod 5, understand?
So how is it 1?
क्योंकि 6 है ना एक इससे कम है ना यू मल्टीप्लाई
Oh yeah, yeah. Okay, okay, okay.
ओके अभी ये 1 mod 5 है अगर मेरे को 1 mod 5 है तो s इज 1 mod 5 मतलब s क्या होएगा अगर मैं और दूसरा वेरिएबल लूँ
5p plus 1.
5p प्लस 1 तो किधर रखेगा ये वाले में रखेगा ना क्योंकि इसी
हाँ.
मैंने इसी से लिया था ना तो x इज इक्वल टू 77 5p कितना था बेटा +1 plus 24 no so x is equal to multiply 7 5 21
385.
3
85.
85 plus 77 plus
The
20
385p.
85p
Yeah.
ठीक है 385p
Yeah.
so x is 385p plus you add what will you get here
That's gonna be 101.
कितना
1.
101.
101.
101.
1 and 1. So if you divide this by 100,
Yeah.
by that number, this is your number. So if you put 0, then 101 is the first number. It satisfies all three conditions. Check it. 101 if you write here, it will give one remainder perfect. 101 divided by 7. So you know 98 is the number which is multiple of 7, then plus 3. That is also perfect. 101, 11, 99 plus 2. It is working. Agree? So isn't that this is so the
Yeah. I just have
question
to remember the procedure.
flow. And once you there one question max comes, then to do that, like if once you do 10 questions, you get used to of it. Understand? So this kind of concepts also they ask. So it is like last time I did it was like very fast, so they didn't understand. Even I was not 100% sure because I thought कि मैं ऐसे करूंगा तो समझेगा कि नहीं समझेगा, तो एक्सपेरिमेंट में चले गया था, अभी समझ में आया। अच्छा क्वेश्चन है। अब सोच इतने बड़े बड़े तो इसको ऐसे नहीं आता, दे गिव वर्ड प्रॉब्लम, they convert me some number is divided by this, then remainder is this number divided what is the first positive integer or second positive integer, or the same number divided by this, what is going to be that again. These kind of like screwing question they ask. And number theory is too much now in the paper. In the AMC also IOQM is 35% was number theory last year. If you master number theory, then like IOQM also is not difficult. But not in 10th grade. Of course, you have to do 11th grade, 11th, 12th grade. So you understand this? Book?
Yeah.
अब मैं देखता हूँ कि what concept is remaining for 20 minutes we can do it. This you understand properly. I think नया ना करके थोड़े मतलब इस पे से मैं साइक्लिसिटी से कुछ क्वेश्चन करने की कोशिश करता हूँ नोट से 20 मिनट. Let's make some question from that and then do it. देखो, these are cyclicity notes. What cyclicity means, how they repeat. If one digit cyclicity means when you divide it by 10, how that repeats. Okay. So then one type of questions are those. Second type of like questions are when you divide by like 100 and then other divided by 1,000. So this note I made, if you see, it is very beautifully made. First is this now. Like, see, if you want to divide it by 10 and you get these at the unit place of any number, just like you have 121 and you divide by 10, and you know, of course, this is going to be 1. No, this means not. You putting like, this means any power you putting, like, see, a raised to n. So, like, your 100 yeah, 121 raised to n. Okay. And if this unit place is 1, 0, 1, 5, 1, then remainder is going to be always 1.
Okay.
Understand that the same digit repeats. If you have unit place 4, so it repeats 4, 6, 4, 6. You can see if you have 24 raised to 1, it is 24. 24 raised to 2, it is something 76. 24 raised to 3, you don't have to think, you just write 24. Like 2 digit if you want. Okay, so that's how it is 4, 6, 4, 6. Okay. So if someone is saying, okay, bhaiya, I have 124 raised to 100. What is the unit digit? You don't have to go and see it. So if you write 1 here, you're getting 4. If you write 2, you're getting 6. If you write 3, you're getting 4. You write 4, then you'll get like 3, then 4, again 6. So
Okay,
that
so
is
that's
even
right.
number. So like at all even places, you have 6. So if any number like this, which ends up this, if I say 1, 2, 3, 4, 5, 6, 7, and then 4 raised to 200, 2000, then what is the unit
gonna be-
digit? So this is even, na?
Yeah.
Even, so 6.
6, so yeah.
Okay.
Yeah.
So it is like that, a unit place. So end up by 6 also cyclicity is like see, first 6 cyclicity is 1. So means any big number you have, if you divide it by put any power, then you're going to get unit place as 6 also. Okay. Second, like cyclicity 9 पे क्या होता है? Just like something 9 you have, just like 4 9 raised to 1. You will get 4 9, 4 9 raised to 2. You will get again 8 1 something. You will get 8 1. You will get then 4 9 raised to 3. You will get again something 9. You will get 9 9 1 9 1 like that.
Okay.
Okay. समझा? So that's how you get it. So अगर मेरे को someone says,
What does the period mean? One frozen the
मतलब frozen means 1 is always comes, like first digit only always comes. One frozen means one number only come, meaning of that. मतलब here 2 different numbers only come, here 2 different numbers. If you unit digit is 9, 2 digit only comes. Unit digit is 2, then these are the cycle that you see.
Okay.
If you
So
4,
that's
like
the
if you
frozen that.
those are the frozen dot. Now 2 raised to, agar if I have 100, so I should know 2 raised to 1 what it is coming, 2 raised to 2 what it is coming, unit digit 4, 2 raised to 3, then 8, 2 raised to 4, then 6. Up this, if you add 4n plus 1, because it repeats at 4. So 4n plus, see, technically you see 4n plus 1 is this first one, is 2. Agree?
Yeah.
If you write 0, then you will get 1. So 2 raised to 4n plus 2 is always unit digit 2. Please 2 raised to 4n plus 2 unit digit is what? 4.
Yeah.
If you check it, if you write here like 1, what will you get? 2 raised to 6.
6.
2 raised to 6, 64. So isn't unit digit 4?
Yeah.
Okay?
It's 2, 4, 6, 8, 6.
2, 4, 8, 6, not 6. 2, 4,
8, 6. Yeah.
and that too for 2. For 3 also you have 3. You can relate it this way, 3 raised to 1, 3 raised to 2. Okay?
Okay. So there are multiples of that many.
So 3 raised to 7, 3 raised to 3. So remember के लिए एक तरीका है. 3 raised to 1, 3 raised to 2, 3 raised to 3, 3 raised to 4. So these 4 only repeats. 7 raised to 1 is what? This. 7 raised to 2 is what? This. Unit
Okay, so
digit.
that's
7
the
raised to
you were
3,
taking
7 raised to 43, this. And 7 raised to, Riddhi, what was 7 raised to 4 is like 2, 4, 0, 1. Agree? 4. So these 4
Yeah.
are the rest, like if you put any power, then you have to make the rule of this for cyclicity 4. Okay? So if I say 7 raised to, sir, this है, so what are you looking for? 7 raised to 4 into something plus 2, no?
Yeah.
Okay, so basically you're looking for 2 only, no? So 1 was what? 1 was like 7 and 2 was what?
9.
9.
Okay.
So 7 raised to 8 is what? 8 raised to 1, 8 raised to 2, 8 raised to 3, what it is? Like see, this may say 8 raised to 1 is like 8, 8 raised to 2 is what?
4.
8 raised to 3 is what?
2.
8 raised to 6.
Yeah.
So 8 raised to 1 matlab 2 raised to 3. 8 raised to 2 matlab 2 raised to 8 64 का 4 ना. 8 raised to 3 मतलब
2 raised to 9.
52. हाँ, तो ऐसे करके मतलब ऐसे दिमाग में इमेज बना लो कि जिससे तुमको आ रहा है. इससे यार बस रिमेंबर दैट 0 1 5 6 cyclicity 1, फिर then 4 cyclicity 2, 9 cyclicity 2, 2 cyclicity 2, 3, 7, 8 cyclicity 4. Okay, so you don't have to think much, you can directly get answers. Now, if you divide by 100 means how the repeats if you divide by 100. Okay, so you look into that number, 5 raised to n. So if you have 5 raised to 1, what is the unit digit? 0, 5. 5 raised to 2 is in 120. 5 raised to 2 is 25. 5 raised to 3 is what? 125. So last two digits except 1 is this.
Yeah.
Okay. So if n is not 1, any other power you have, then cyclicity is going to be what?
20.
Huh?
25.
20. If you have 7 raised to, like, see, cyclicity of this, now cyclicity of this is what? 5. If you have 7 raised to 6 raised to n, okay, so the cyclicity is 5.
Okay. Yeah.
If you do
Okay.
mod
Got it.
100, then cyclicity is 5.
Yeah.
So can we prove that cyclicity by using some theorem?
Yeah.
Okay, so 6 raised to tosant functions of 100 congruent to, ठीक है, 1 mod 100. Agree? Any problem on that? 100, not 1000. So what is tosant functions of that?
That's
The
it.
tosant function of 100 is 40.
40. Yeah.
40. Agree? So tosant function, so 6 raised to 40 will give 1
Mod.
mod 100. Now, how you break it into the smaller number? Okay, like 6 raised to 40, you have to find out 6 raised to 5 is what?
Yeah, it's that 56.
6 raised to 1 is what?
30. I know 6 raised to 1 is 6.
This one is what?
6.
That, like, see, remember, this is highest power. That can be lesser power than that.
Okay.
Okay, that comes from this function. This function. This function says you have to decompose into 2 co-prime. So 2 co-prime of that is what? 4 and
25.
25. So
25,
tosant
yeah.
functions of odd numbers is 20. The function, this function using for that is 1. So actually cyclicity reduced to 20. Understand? Now you further reduce it to like this 6 you have to do.
So how did it reduce to 20?
See, there is one more function. If you read these proper documents, there is rule. If you have like 25, any odd number, the tocent function is the same as you calculate. Okay. But if you have even number, so 2 raised to n minus 1 it becomes. So just like 100, like 1000 you have. Agree? Normally you can divide it into 20, like 125. So tocent function of this is 100. But the factor I was talking about is 2 raised to 3 now. This is 2 raised to 3,
Yeah,
na?
yeah.
So the function says the cyclicity is, that is the largest cyclicity. The other cyclicity of that is lowest is 2 raised to n minus 2. So if you
Okay.
fit in 2 raised to n minus 2, 3 minus 2. What is 2? So you multiply both number, this and this. So the 100 and 2, so 200. Agree? So that's how you have to learn a lot of things. Just as of now, just don't go into that depth. Just look into cyclicity of 6 raised to 10 is 5. Okay, 6 raised to 1 is what? 0, 6. That does not follow the cyclicity. 6 raised to 2 is what? 36. 6 raised to 3 is 256. So we will take 216. So we'll take 16. 6 raised to 7, whatever you said, 96. So these are the 5 digits repeats,
Okay.
except that is valid for n is equal to 2 or more.
Okay.
Okay, cyclicity of 7 raised to n is what?
It's 7, 49, 43, 01. All these.
7 raised to n is what cyclicity?
7 raised
4 only. See, perfect. This is like 7 raised to
Yeah.
1 cyclicity is 4, 7 raised to 2. Like if you divide by 100, then the cyclicity is also same as 4.
Mhm.
So those only 4 repeat. Reason is simple. If you do 7 raised to 4, it will give you what? 2401.
Yeah.
So if
0,
it gives you 0, 1, then you can multiply. If you do 7 raised to 5, you multiply 7, it gives 0, 7. So you start repeating same now.
Mhm.
Cyclicity of this is 4. 76 is a number whose, if you divide it by 100, you get 76.
Mhm.
So any number, any multiple of 7 raised, any power of 7 raised to 6, 7 raised to 6, 1, 2, 7 raised to 6, 3, the number, if it is, then always you'll get 736 if you divide by 100.
Yeah.
The cyclicity of this number is the number which having 1. This cyclicity of this number having 1. Cyclicity of this number having what? 24 cyclicity is 2. 2476 will
What
get.
is ping pong?
Huh?
It says 76 ping pong.
हाँ, मतलब दो नंबर आते तो they named it like what 24 76. Even place will get this, art place will get this.
Okay.
ठीक है. This you need to learn for binomial distribution that you haven't done much. So you don't need to do binomial distribution. Like अभी तो is too early, अभी 5 minutes 10 minutes बचा, तो I can't do binomial distribution. I'll do binomial distribution and tell you. And you can use it this from here. It's very useful theorem. If you want to get last 2 digits of any number which is like close, one before one after of multiple of 10, then it is too easy. Just like if I have 100, 21 and raised to 200, I'm saying what are last 2 digits.
Mm.
So this theorem, if I try to fit, how I write 10 into
Will become 120 plus 1, so 10 into 12
10
plus
into
1.
12 plus 1 raised to 200.
Yeah.
So says like you 10 into 12 into power, no?
Yeah.
200 plus 1. So if anyway 2 more than 2 0 is going to answer is going to be 1 1. Understand?
So wait, how? I'm confused. Wait, what did
See,
you do?
this is the rule. Read this very carefully. What it is. The
10
number 1 more than multiple of 10. So 121 was 1 more than multiple of 10.
Yeah.
You break it into like 10 into 12 plus 1.
Yeah.
So from here 10 is fine, t become 12.
Yeah.
Agree?
Yeah.
Anyway 200.
Yeah.
So last 2 digits comes from this. So 10 into t was the number which is 12 here, and then
200.
n is 200 and plus 1. So this is anyway more than like 100, so the remainder is 1.
Okay.
Okay. So if you increase, now you won't take that kind of power. You take suppose or like 1, 2, 3, then it will be handy. So 10 into 1, 2, 3, okay, plus 1. So this getting like this you multiply 1, 2, 3, 0 plus 1. So 31 is last 2 digits.
Okay, got it, got
Okay,
it.
that's how it helps you and it's very useful. So this cyclicity is very useful to reduce and to get last 2, either use CRT. इतना
So how do you
detail
use CRT? इसमें CRT कैसे यूज करते
इस पे सीआरटी वही अपना सीआरटी का जो मेथड है हम वही से चालू करके करेंगे, लास्ट डिजिट निकालेंगे और हमारे पास कोई ऑप्शन ही नहीं है। जैसे हमारे पास 121 होता, अगर मान लो 121 रेज टू 100 एंड मॉड लाइक इफ यू वांट टू डू 100, then there's only one way, break it 4 into 25. Just get that like remainder for 4 and get remainder for 25,
Yeah.
and then combine it by using CRT. Okay,
Okay.
so that is too long process. We get objective question. We have to tick mark only to that you can do for IOQM because this question they ask. So, understand?
Yeah.
So this was, then I'll move ahead with last two cyclicity. थोड़े से और डिटेल में जाते हैं। लास्ट टू cyclicity पे क्या होता है, 5 यूनिट डिजिट इज 0। सो आपको समझता है सब,
हाँ।
ये तो पता ही है, इसमें से कुछ वो नहीं है। अब लोग थोड़े पीरियड पे चले जाओ तो तुम आपको थोड़ा साइक्लिसिटी 20 देखो, सबकी साइक्लिसिटी ऑलमोस्ट 20 ही रहती है। देखो इन सब जहां से एंड हो रहा है 1 3 7 9 साइक्लिसिटी इज व्हाट, जस्ट लाइक
20.
इफ यू सी you number you take cyclicity is what 20, so
हाँ.
सबका cyclicity 20, इतने सारे नंबर लिखे हुए end
Sir?
with 1 3। हाँ बेटा,
Sorry, पूछ रही थी कि how many cyclicities do we have to remember?
you don't have to remember because the question may be come once, for that you don't have to put that much effort. For a smart calculation you should know these which is getting reduced to, just like this. Abhi if say someone says 7 raised to like 100, like 25 raised to 200, what are last two digits? So options like 25 is going to be last two digits only. If you have 6 raised to like 100, what is like last two digits? What is 10th place? So these kind of question you have to be quick because like 6 raised to 1, cyclicity of 6 raised to n up to digit is what? 5. 6 raised to 1 is what? 0 6. 6 raised to 2 is 36 and then repeats. So you can say 6 raised to 5n if n plus 2 or 1 plus 1 no is what? 0 like 36 no, two digits.
Yeah.
If you write no, this 2 is 36. Okay, if you write 0 then you get 6 raised to 2 2 and this repeats. So 6 raised to 5n plus 5n plus 3 is going to be the next that you have 16. Agree? So you have to break into 5 raised to 5n plus 2 and 3. So 100 is what? 6 raised to 5n no?
Yeah.
So if you want to get the last two digits, you can write it as 6 raised to 49. ठीक है, 5 पे करेगा तो क्या आएगा, 5 इंटू 24 23, 24 करेगा तो 100 आ जाएगा।
Yeah.
24 करेगा 100 आएगा। 23 प्लस व्हाट विल राइट हियर, हाउ मच रिमेन, 5 raised to like this is what 5 into 24 is 100.
Yeah.
Okay,
Mhm.
but you don't have to, then you write here what like some numbers, but this number
Why 5 times 20 only?
तो 23 बेटा, तो 5 times 23 is what?
Just 20. 5 times 20.
5 times 20 is 80 only. Now you have to go to close to 100. So 5 raised to 21, 23 is what? 5 raised to? You can write 5 raised to 23 plus 5, no? Understand?
Yeah.
So 5 raised to 23 plus 5, because 5 raised to 24 is what? 100. If 5 into 24 is 100. So if you want to break it, you can break it like this, no? So this number comes when 5 raised to 2 is there. This comes when 5 raised to 3 is there. This comes when 5 raised to 4 is there. This comes when 5 raised to 5 is there. So this is multiple of 5. This disappears. So this would give you as 6 raised to 5. 6 raised to 5 number is what? 76. So last two digits of 6 raised to 100 is what?
56.
अब चेक कर, मैं जिसे नहीं, ये तो 2 पे आ रहा था ना पावर पे,
अच्छा,
ये 3 पे आएगा,
हाँ,
ये 4 पे आएगा, ये 5 पे आएगा ना, तो 5, तो that's what we have to multiple. So you have to eliminate multiple of 5 and such that you will get a number which is either 5 or lesser than 5.
Yeah.
Okay, so you don't have to use CRT or anything like to do all of that. The cyclicity will help you out. So 6 raised to 2 like 5n plus 2 is cyclicity. If you write here 0, 6 raised to 2 is 36. 6 raised to 2, 6 raised to 3 is what? 1 6 last two digit beta. 6 raised to 3 last two digit what 96. 6 raised to 4 last two digit was 76. Last 6 raised to 5 is 56. So if someone says, okay, bro, you have 6 raised to 1005. What is the cyclicity? You use a 6 raised to, this is anyway multiple of 5 plus 5, no? So then you have to get multiple of 6 raised to 5. This is right, this is gone and then 6 raised to 5 anyway, that appears over there. 76.
Hmm.
76 नहीं, that is 5 पे 76 है,
हाँ.
perfect. अगर 6 होता तो
6 होता तो 56.
that's how you do like this combined 6. Understand? So मतलब 5 into 1 plus 6 plus like 5 into 1 plus 1. Okay, then 6. Because this is starts from 2. Like this is start from 2. So understand what I'm saying? So if you write here 1, then you get 7. 7 wala power is what? So you have to go like home and then
back to
this is like 7, 2 wala ye hai na? देख calculation is ये कितना है?
it goes to 16.
हाँ तो ये it comes here ना 6n plus 2 पे आएगा अगर like 5n plus 2 n 1 7 raised to 6 this is 2 3 4 5 6 नहीं 2 2 3 4 5 6 6 पे आएगा तो 1 रखेंगे मतलब you have to find out the way ठीक है ठीक है इसका 4 है ये तो बहुत आसान हो गया if I write 7 raised to 200 and I'll say भैया what are last two digits of that so what you'll do
Okay.
you write 7 raised to 4 into something
Yeah.
and 7 raised to 4 perfectly the cyclicity is 4 7 raised to 4 is 2401 so the answer is 240 okay that's how it is like you have to think co-prime and a lot of things that you have to do this I would take like half an hour more to like explain these functions and then how it comes and this थोड़ा सा इधर भी और थोड़े reduce के लिए एक क्लास में अच्छे से रिवाइज कर दूंगा इसके बाद आई हैव टू डू नंबर बेस्ड डॉक्यूमेंट इज प्रिपेयर्ड प्रॉपर्ली एंड देन थोड़ा मोर देन फुल दिस इज डन देन आई got the past paper segregated. There are 45 questions of all all AMC papers.
Yeah.
So I just cut paste and upload, cut it, paste it already there, and then I synchronize. So next class is going to be based on that and finish it off. So this is done now. My problem sequences will take one class, and I'm going algebra. I did fill algebra because these kids they haven't done modulus and all, so they found it very hard last class.
No, I've done it in programming. So
I'll tell you this. I explained to one girl. So today I upload and send it to so that they can watch it and then they can understand next class when I do it again of that quadratic they did. हाँ बेटा
Is this the class I missed?
this class you missed and I feel like the other kids also didn't understand. This was little harder. So I had to do one basics class. So I did with one girl. This basics, the video of this is available. I'll send it today only. Then redo it again. Then they'll understand because this algebra is like too much. It needs a lot of practice to get used to. Number theory is a concept clear than concept clear. That is why number theory does not need much. So then polynomial is too heavy and solving equation is too much variation from it. So this build may take 1 month to complete, but parallelly our aim is to do this on Wednesday and this on number theory and PNC on Saturday. So that way we slowly will finish. Aj I'll give a lot of homework to you guys. Okay. So that's what it is. So I'm just now going by. I'm very happy. Class was very good today.